Hello, welcome to a video to introduce some of the code that's in Lesson 7 of Unit 8.2. So there's actually three programs in this lesson. One is Program Z, which is actually just a really simple program to reset the microbit. We're not going to dig into that. Instead, we'll look at X and Y, which look really similar on the surface, but actually have some important differences underneath. And students will work together to modify one of these to meet their needs as a class. So here we have program Y, and we're starting with Y first because it's more similar to what we've seen before. Notice we have these sections that say on start and forever, and down here there's some different functions. These functions are important because they break out pieces of code that are all happening in here. So these are the key parts of our instructions that tell us like what order to do things in, and then it takes us to these, as we've seen before. But if you compare to the code for program X, you'll notice that has a very similar structure at the surface too, but then deep down, it's got some differences. The other important thing to attend to here is we have all these if statements. We saw these in lessons 4 and 5. What the if statements are doing here is they're essentially serving as kind of a counter. They're telling it that you should flash this heart 10 times and then go to the next step, which is to play and hold the note 10 times. And so it flashes the heart, it plays the notes. Whenever it plays the note, it clears the screen. And then when it's done, it stops all sounds and it makes a little check mark. Pretty straightforward. However, if you look at what the code itself looks like, it's messy. It's kind of convoluted and complicated. If we compare that to program X, which appears to do the same thing, we'll actually see it seems a little bit tighter. There's a few fewer boxes in here. And the way it gets away with that is using something called loops. Now, students have actually seen loops for a long time without realizing it. Like these forevers right here, all that does is it tells the microbit to do the same thing over and over again forever. For some reason, it's not in this loops box. It's up here under basic. However, it's still a loop. The loops that students encounter here are essentially repeating 10 times. However, we could easily change that number to anything else we want. And so there's actually other types of loops too. Students may bring these up if they're familiar with programming. If not, it's not necessary to introduce them right now unless you feel it will be helpful in the future. So there are also these while loops, which basically look for a certain condition. And if that condition's true, it runs, or if it's false, it runs, just depending on how you set it. There's also these loops here, which basically repeat the code every certain number of milliseconds, so at a set time frequency. You could use that instead of doing some sort of pause in this forever loop, as we've sometimes done in the past. And so this is a much more straightforward way to do things. Students in this lesson can propose modifying either set of code to meet their requirements. The requirements that they have here that we really want them to emphasize is we want there to be some sort of timer. We don't want this to start the beeping until we get it into the container. And so there's different ways you could do that. One of them is if students like this heart icon, they can actually just set the heart icon to run a longer number of times. They could do that by increasing the counter number here if it's program Y, or if it's program X, they could say repeat more times. Either way works. Students also could make that happen by putting in a delay. Now, we've seen those types of delays or pauses before. They're up here under basic. It's written in milliseconds. So if you want to go beyond 5 seconds, notice 5 seconds is 5,000 milliseconds. Students can think about, okay, if we want to go to 20 seconds, how much longer does that number have to be? Turns out to be 20,000 for 20,000 thousandths of a second. But the important thing to attend to is where this block goes. So you could put it lots of different places. I would encourage you to work with students to help them experiment with it. However, where it has to go to actually work in either one of these programs is probably right here as the easiest location. The other thing that students can and probably do want to change in some way is if they want to change the symbols or the sounds. They can change the symbols here. They can also go to the basic menu if they really wanted to make custom symbols. However, there are a lot of options here. And then if they want to change the sound, that's change the icon again. Probably want to leave that the same when it's making the sound, but you don't have to. This frequency of note is something that actually is dictated all the way back here. So if they want to change that note, they can change it back here. If they want to change the volume, they can change it on start. So there's different possibilities for students to tinker around. Thank you for watching and enjoy the lesson.